Let's talk about decorators in Python. Even though decorators are a general design principle in software engineering, in this video I'm going to discuss how decorators function and operate within a Python context. I am not just going to show you how to create your own decorators, because that would be rather pointless. Instead, I want you to understand how decorators function under the hood, so that when you create your own decorators, you know exactly what you're doing and how to tailor them to any need that you want. So, let's dive in. Instead of just dumping a bunch of decorator code onto the screen, I want to discuss the most important concept behind decorators first, which are functions. Remember that in Python, everything is an object. Functions are also objects. This will be very important later on. So let's discuss first how functions work within an object context. For this, I'm going to define a few type hints that'll help me clean up the code a bit. I have two very simple functions, a multiply function and an add function. Both functions take a float or an integer as input argument and return one accordingly. As I mentioned before, functions are objects. That also means that you can pass functions into other functions. For example, here is an apply function. This apply function takes another function as the first argument and then two numbers as the second and third argument. Inside the apply function, we call the original function that we passed in and we pass into it the two arguments. Here are two examples in how we can use this. We take the apply function, we pass in one of the two other functions, add or multiply, and we pass in the two arguments that we want, in this case the number 2 and the number 3. Now if we run this, the apply function takes the add function and adds 2 and 3 together. And in the second one, the apply function takes the multiply function and then multiplies 2 and 3. Which is exactly what we get in the output. Okay, this is nice. So we can pass functions into other functions. As I mentioned before, functions are objects. That also means that we can assign objects into a variable. So I can take my multiply function and I will assign it to the op variable. If we then print the op function, it should print out the reference to the multiply function. And if we print the result, so if we call the op function, it should call the multiply function. So let's run this and see what we get. Nice, exactly what I expected. So the first print statement prints out that it's a reference to the multiply function. And the second print statement actually shows what happens if you call the variable that has the multiply function assigned to it. This is neat. So we can also assign functions to variables and we can pass functions into other functions. The third thing we can do with functions is that we can return functions from other functions. So let's say I have this function choose function to apply, which passes in a name, and based on the name it chooses whether or not to return the add function or the multiply function. If we then call the choose function to apply function, we can assign its return value into the choice variable. And like we did with the multiply function assigning it to the op variable, choice will now basically have a reference to the add function. So while running this, we see that this is exactly what happens. We print out the reference to the add function, and lastly we see what happens if we call the choice function, which has a reference to the add function. Small note here, since the choose function to apply is in fact returning a function, we could also just call the function directly without assigning it to a choice variable, which is what I've done here. So we have the choose function to apply, we pass an add, so it returns a reference to the add function, I call it immediately with the parameters 2 and 7, and I store the result in result. So if we print the result, we should be getting 9. Nice. So to recap really quickly, functions are objects in Python, just like everything else. We can pass functions into other functions, we can assign functions to variables, and we can return functions from other functions. These three concepts are really important if we're going to discuss decorators. What I'm going to do first is create a function that does something really simple, and then we're going to build that out to accept a more and more complex decorator. So in this case, it's just going to be a function called a database operation that does nothing else than just sleep for 1 second. Now, the function itself isn't really interesting, but what I want to do is I want to time how long this function takes and then log the duration. So I'm going to import perf counter, which is really nice for calculating how long operations take within Python. I'm going to take a time sample before the sleep operation. I'm going to take a time sample after the sleep. I'm going to calculate the duration, and then I'm going to debug log this duration. Now, if we then call this function, we can see that it actually prints out the log statement, which is nice, and it shows us how long this database operation took, which is approximately a second. This is great, it does what I want it to do, but it isn't really very composable. Because what if I want to have a different function that I also want to attach this logging functionality to? And that's beside the point, because I've now cluttered my original function with a bunch of stuff that I don't really want in there. That is where decorators come in. Because decorators allow you to add functionality to a function or a class without changing the implementation of that function or class. And that is exactly what I want to do here. Now, here is the database operation function that I had previously, just removed all the clutter. For decorator level 1. I'm going to create a timeIt function. I want it to time how long a function takes and then log the duration. A general structure of a decorator looks like this. We start out with the name of the decorator, so the name of a function basically. In this case, it's called timeIt. The timeIt function takes the original function as function argument. Within that function, we can define a second function, usually it's called wrapper, which takes a bunch of arguments and keyword arguments. And then within that function, we're going to call our original function with the arguments and keyword arguments that we've passed in. So we've defined a function within a function, and then we're going to return the wrapper. That means that if we call the timeIt function, it actually is going to return us the wrapper without calling the wrapper. So this might seem complicated, but let's rip it apart a bit. So in fact, what's happening is that we can pass a database operation into the timeIt function, which then returns the wrapper, and then we call the wrapper. And that internally calls the function and returns us all the return values. In this case, I don't have any arguments or keyword arguments, so I'm just going to leave this empty. But structurally, this is what a decorator does. It's just a function that takes a function argument as its first argument, and then within that, it returns a second function that actually calls our original function. Now let's add back in all the logging stuff that we had. So this is starting to look like the function we had before. So within the wrapper, we start with a counter. We call our original function. We end the counter, calculate the duration, send the duration to a debug log, and we return the value if our original function had returned the value. If we then call this function that I have here on the bottom, so we pass in a database operation to timeIt, and then we call it, we should be able to see, finally, this debug statement again. And we do. So we've created our first decorator. This decorator is able to just take a function, calculate how long it takes, and then log it. And we can pass in any function we can imagine into this timeIt function. It's just not very convenient to write. And that is what a bit of syntactic sugar that Python adds to decorators helps us with. So we can add the timeIt function as a decorator to our database operation function. Let's remove this. And this bit, this add symbol and timeIt, is just syntactic sugar for simply calling the timeIt function and passing in the original function that we have. It just looks a bit nicer and it's easier to manage. If we then call our function a database operation, we should get the same output. And we do. So congratulations, this is the very first decorator and also the simplest decorator we can imagine. Now on to decorator level 2. It might be just me, but I find this decorator rather limiting because I can't really specify how the decorator exactly works. For example, this perf counter is pretty nice, but it only counts in seconds. What if I want to customize the decorator to sometimes count in nanoseconds and sometimes just in seconds? So let's start adding that to our decorator. That basically means that this decorator needs to accept an argument. So, for example, I just wanted to accept a useNanos boolean that sometimes is false and sometimes is true. And based on whether or not it's true or false, we can specify how it logs the duration within the decorator. But currently that's not really possible, because the timeIt function itself takes the original function as argument. So how do we fix that then? Well, remember that decorators are just a bunch of nested functions, so the only thing we have to do is create another level of nesting within this. So here we go. I've basically added another nesting within our function. I just called it funcWrapper because I have no clue what to call this, which takes the original function as its argument, then does the same thing that our original decorator does, which is defining the wrapper and then returning it. And then we can make this timeIt function accept arguments. Also note that I've done this the correct way here by specifying an asterisk, which means that everything that comes after that has to be a keyword argument, otherwise the compiler will complain. So if I make this just a boolean, it actually says, hey, I don't understand what this positional argument is because I don't accept positional arguments, I only accept keyword arguments. Which is very nice, especially for booleans, because having just a bunch of true and falses within function arguments isn't really readable. Let's go back to our intuition in what this actually does. I'm going to remove the decorator syntactic sugar for now, and I'm just going to call the timeIt function. Well, as expected, it actually returns a reference to the funcWrapper function. Since funcWrapper is a function, we should be able to call that. And since funcWrapper takes the original function as an argument, I'm going to pass in a database operation. Okay, so now I've chained two functions together. I've chained timeIt and funcWrapper. If we then run this, we will see that it actually returns a reference to the wrapper function. Almost there. The only thing we have to do now is call the last function again. So basically we've now been calling timeIt function, after that immediately calling the funcWrapper function, and immediately after that we call the wrapper function. And this finally should give us the log statement. And it does. So this is kind of how this decorator stuff works. By just nesting a bunch of stuff, you can add more functionality and more levels to it. Now let's add back this decorator syntactic sugar. And remove the other one. Let's run this to see if it still works. And now the only thing left to do here is to actually use the flag so we can switch to nanoseconds when we want. There we go. That should do it. Now let's test it out. So without the flag, it still neatly prints the seconds. And adding the flag back in, it actually prints the nanoseconds. Great! Level 2 completed. Now there is one problem. To visualize what's going on, I'm going to print out the help for a database operation. And let's see what it returns. It prints the help for the wrapper function. That's not really nice. If we now decide to generate docstrings to put it on the website, it will generate the docstring for the wrapper function. So let's fix that. And by fixing this last issue, we enter level 3 of our decorators. Luckily, the fix itself is really simple. Python, of course, knows about this problem, so it actually comes with a helper decorator to fix this problem. We can import functools and then use the wraps decorator from the functools module. And what this wraps function does is actually quite nifty. It takes a bunch of properties from the func function and copies them onto the wrapper function, so it appears as if the wrapper function was the original function. And if we now run this, we actually see the correct help statement for the right function. Python wouldn't be Python if it would fix the problem of a decorator with another decorator. Since you now know that decorators are nothing more than functions that are returning functions, you should also be able to see that decorators can be stacked. So let's, for example, assume I have a new decorator with an implementation that isn't really important right now. Then I can just add this new decorator as a decorator to our original function as well. Now don't worry about compiler errors for a second, but you can reason on the order of which the decorators operate. And the order is important. So if we write this out, it's actually going to be like this. So we basically have the new decorator, and we pass the entirety of the timer decorator into that new decorator, which then in turn passes in the useNanos flag, then calls a database operation with a few arguments. So you can imagine that the new decorator can have a piece of functionality that is dependent on the order of whether or not it's called before or after the timeIt function. Because if we change the order of decorators, so if we say new decorator after timeIt, it's going to flip the order of the function execution as well. And this is basically everything that there is to decorators in Python. So a few key takeaways here is, first off, functions are objects. Functions can be passed into other functions, they can be returned from other functions, and functions can be assigned to variables. Decorators themselves are just a bunch of nested functions that are called in order. And lastly, a decorator is nothing more than a function that adds functionality to a different function without changing its original implementation. You should be ready to create any decorator you want. Happy coding!